Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning guys. Good morning Jiva, Chini, Liu, Abby, Shikin, Pichong. Umi, morning Umi. Morning guys. Salam Najwa. Okay, so I hope you are ready to discuss new topic today. Okay, Waalaikumsalam Nisa. Izazi. Hi Shah. Yes, saya tahu awak Shah. Okay, so alright. Now we are going to discuss topic 6. Okay, so class monitors have come and collected the summaries, okay, of topic 6. Alright, so now I hope you may refer the summary. Okay, so we are going to summarize this topic after the discussion. Okay, and we'll see the progress. Okay, so now let's begin. Okay, so I'm going to share this with you. Okay, so topic 6. Okay, now let's see the list of learning outcomes that we're going to accomplish today. So I'm targeting to discuss 6.1 and some of 6.2 objectives. Okay, so we are going to accomplish this 6.1. Okay, we're going to identify the discrete and continuous data and identify ungroup and group data. And we're going to construct and interpret stem and leaf diagrams. Okay, so now let's see. Okay, so 6.1. Okay, so I would like to apologize for the late uploading, okay, the notes in the Google Classroom because I was just improving the notes, because again, in order to accomplish quite a lot of outcomes within a very short period, so I cannot simply use the previous lecture notes that we've been using for years. Okay, so because this is quite special, okay, the amendments been made. So okay, so we have only short period of time to cover this quite a lot of learning outcomes. Okay, so that is why I need to really go through the notes, seeing what is important and what is not. Okay, so that okay we will be able to finish the contents on time. All right. Okay. So now 6.1. Okay. So let us discuss these learning outcomes. Okay. So beginning of this topic 6 is all about statistics. Okay. From topic 6, data description, and then followed by topic 7, permutations and combination. Okay. I just noticed there's one question in the left chat. Okay, so Mai asks, Madam, nota topic 6 ada tak? Yes, ada dekat Google Classroom. Okay, I just uploaded the notes this morning, and I'm sorry for that, okay, for the late notice. Okay, because again, so I need to really improvise the notes, okay, so because I was having a course yesterday, so I didn't manage to finish yesterday. Okay. Yeah, okay, no problem. All right, so thank you, Jiva, for understanding. All right, okay, so now let's begin. Okay, so let's see statistics. So statistics is a science, right, that deals with collecting, organizing, summarizing, presenting, and analyzing data in order to obtain useful information for decision making. Okay, so statistics has a wide range of uses in the field of science, business, industry, economy, medicine, education, agriculture, and so on. Okay, so you see that statistics has lots of applications. Okay, and not only mathematicians do apply statistics, and in fact, okay, politicians also, they do apply statistics. If you can see example here in the field of science, statistical techniques are used to analyze data that is created from the experiment. So just like when you do the practical, right? Practical for biology, chemistry, and physics, when you do the experiment, so you take some readings, right? Okay, and you jot down the outcomes. So that is actually statistical techniques, okay? Because you collect data, you organize data, then you also summarize. Not only that, sometimes you do present the data to lecturers and you analyze the data. So actually, okay, you have been applying statistical techniques, huh? But you just don't realize it, all right? And in the area of business, marketing surveys are carried out to determine the compatibility of the product with economics and social demand. For example, okay, when you purchase the iPhone 12, and then we can see the trends, okay, the trends of the devices, okay, so we can see the leading brands and so on. So from there, okay, they can use the statistics about the number of sales, okay, and the number of demands, for example, okay, in order to come up with a new and latest technology. Okay, and here in the formation of national policy, so data from the census is used in economic and social planning. Okay, and if we try to apply this in the recent situation, in the current situation, so let's talk about COVID-19 vaccination. Okay, so the government did take the numbers of nations who had registered for the vaccination. So from there, they collected numbers. Okay, they collected numbers, okay, from the registration, yeah, so that they know how many people are interested to get the vaccination. Okay, so Shafa, sorry to interrupt, but the latest note madam upload is 5.4 on 9 March. I think I have just created a new topic. You just go through the classroom, go to topic 6. I just created a new topic 6. Okay. So but yeah, if you can't download the notes yet, you just stay with me, okay, and then you just jot down the examples that we discussed, then later you can, okay, print out the notes, yeah. Okay, morning Shamin. All right, okay, so now let's continue. Okay, so in the field of education, so statistical techniques are used to analyze the progress of students in an examination. So for example, from your UPS results, so after I did analysis, so I can identify how many failures, how many A scorers, and so on. And then from there, I can plan a strategy on what to do, okay, in order to make sure that you perform in PSPM. Okay, so that is the use of statistics, yeah. Okay, and yeah, we know that there are some definitions, okay, but you won't be tested in exam about the definitions. But again, we just discuss, okay, so that you understand, okay, the terms that we use throughout the discussion, yeah. So for example here, population. So population is collection of all elements whose characteristics are being studied, while parameter is a summary measure of a population, such as population means, variances, etc. Okay, and then sample is a set of measurements that constitute part or all of a population. That is, a sample is a subset of a population. And then variable is any measured characteristic or attribute that differs from, okay, for different subjects. For example, if the weight of 30 subjects were measured, then weight would be a variable, okay? So this is variable is something that we look into, okay, what to study, okay? So if we talk about the weight that we want to measure, then the weight would be the variable. Okay, and we do have two types. Okay, it's either quantitative variables or qualitative variable. Okay, so quantitative variable are measured on ordinal interval or ratio scale, while qualitative variables are measured on a nominal scale. Okay, so for example, quantitative we deal with numbers, something that you can measure, while qualitative is something that you can observe. You cannot use numbers to represent them. Okay, for example here, height of boys. Okay, so you can represent numbers, right? So we call it as quantitative data. And what about type of footwear? Type of footwear means you do have different types of footwear. Okay, so you cannot use numbers. For example, okay, type of footwear, sandal, okay, sneakers, or sports shoes. All right, so those are types. Okay, but yeah, they don't represent numbers, right? So that is what we call as qualitative data. And then age of lecturers. For the age, we can use numbers to represent. So we call it as quantitative data. While color of cars. So color, it's blue, red, green, yellow, and so on. So again, we don't have numbers to represent them. It's just, okay, a character that we can observe. So that is qualitative data. Okay, so I hope by now you are able to identify the difference between qualitative and quantitative data. Okay, so now let's see example. So a survey was carried out on 20 boys and girls in a college to find out whether they like the subject statistics or not. So state, okay, so yeah, the solution's been provided, yeah. So state the population. So the population is all the students in the college, okay, using the terms that we discussed. Okay, so the population is basically the whole group, okay, of subjects that we have. Okay, and then the sample is only the 20 boys and 25 girls. So again, 20 boys and girls, they come from the whole population of college students, right? So that's why the population, okay, so we discuss as all the students in the college, while the sample is basically this, the 20 boys and 25 girls. And then the variable, so variable is whether they like the subject or not, and it's a qualitative, okay, because like and you don't like, so that is something that we can't really measure. So it's just a type. I mean, you like or you don't like. Okay, so we don't have numbers to represent the data. Okay, so we say that as qualitative variable. Okay, so again, you can see the diagram here. So we do have two types. One is quantitative and one is qualitative data. So you can see the examples here: age, weight, height, marks. So they are all quantitative data. But when it comes to qualitative, so something that it is not possible to measure. So for example, colors, types of cars, etc. Okay, and now for the quantitative data, we can split into two. Okay, so it's one is discrete data and the other one is continuous. Okay, now what's the difference between this? Okay, so discrete data is a data that assume countable values, something that we can count. Okay, so if you recall topic 1 semester 1, okay, we started with counting numbers, right? Represented by the letter n, right? Natural numbers. Natural numbers are also called as counting numbers. Okay, so again, when you started to count, okay, you started with number 1, right? So number 1, number 2, number 3. So if you count people also, okay, they have to be 1, 2, 3. So you cannot have 2.5 number of people. So okay, so any data that assume countable values, so we call it as discrete data. Okay, so you can see example here: number of students, okay, and then number of cars. Okay, so something that cannot take a decimal value, so that is discrete. Okay, and then, okay, so the keyword here is countable. While continuous, so continuous data is a data that assume any numerical value over a certain interval. We do have interval. For example, you can represent the data using decimal values. Okay, point something point. Okay, so weight, so you can have your weight 57.1, and then, okay, and then tomorrow morning, then okay, you weight your body, then you can see yeah, if you are using digital scale, then you can find it's 57.0. So again, you can see the weight, okay, can take decimal values, right? And same thing also applied to time taken. We can also express time taken in decimal. Okay, and also, for example, temperature. Okay, so temperature can also be represented in decimal. Okay, so basically the difference between discrete and continuous is that, okay, discrete is a countable value while continuous is not. Continuous is just opposite the discrete. Yeah. Okay, so now let's see example. So based on the following statements, determine, okay, whether the data is discrete or continuous. Okay, now we will see the keyword here. So the time taken. So time taken to travel from Ipoh to Kuala Lumpur. So it's either 1 hour and a half, okay, 1.5 hours, or you can have 2 hours or 2.1 hours. Okay, so we can represent time in decimal, right? So it is continuous data. Okay, and then number of pens sold by a stationery shop. So number of pens, it has to be countable, right? Because you cannot have 1.5 pens, all right? It's not possible. So we call it as discrete data. And then, for example, a diameter, okay, diameter of 10 spheres. So diameter, you measure, okay, so when you refer Okay, when you read the readings, okay, on the ruler, so you can have decimal measurements, right? So that is continuous data. And then number of customers, so we are talking about people, right? So people again cannot be decimal, so it is discrete data. And while weight of newborn babies in a hospital, so it can be represented in continuous, okay, as a continuous data. Okay, so that is the example of difference between continuous and discrete. Okay, and this data, whether it's qualitative, usually we will refer the quantitative data lah. Okay, so all this data, okay, for quantitative data, whether they are discrete or continuous, we can represent them in ungroup or group data. Okay, so what is group data? Okay, so group data is grouped in interval. So the keyword here is interval. Okay, and they are categorized into mutually exclusive intervals. Okay, can be presented in frequency distribution table, histogram, polygon, or jive. Okay, so for example, okay, so you can see here what's the difference between group and ungroup. Okay, so you can see there is an interval here. So the keyword here interval. While for ungrouped data, so they are just listed as sequence or in the form of frequency table. Okay, if they are presented in a table, so usually they won't have the intervals. Okay, so for ungrouped data, they don't have intervals, no intervals. So as you can see here, okay, in this table, so number of children in one family, so we just have the number, not the interval. Okay, so this is what we call as ungrouped data. So the difference between group and ungrouped is just the interval. So if you do have interval, so you can call the data as grouped data. While if you don't have any, then you can just call the data to be ungrouped data. Okay, so this is basically we are going to discuss the measures. Measures in statistics, there are two different types of measures, which will be discussed in the next subtopic. Okay, so one is measure of location. Okay, so these measures are used to determine the central value of a set of data. Okay, central value of a set of data. So these are the three measures: mode, median, and mean. So these are the measures. Okay, so if you learn in school, the measure of location is called as sukatan membulat, if I'm not mistaken. Okay, while measures of dispersion here are used, to determine the dispersion of a set of data. For example, range, interquartile range, standard deviation, and variance. Okay, so this will be discussed in subtopic 6.3, and measures of location will be discussed in subtopic 6.2. Okay, so now stem and leaf diagrams. Okay, so what are stem and leaf diagrams? So stem and leaf diagram is used to present and display frequency of a group without losing information. So without using information means we just get the raw data and we arrange them in a table. Okay, so to construct a stem and leaf, so each score will be split into two parts. Okay, the first part is called the stem, while the second part is called the leaf. Okay, so if you try to, the literal meaning of stem is what? Batang kan? Okay, batang pokok ke, contoh leaf is the daun, right? So kalau kita, so this is stem and this is the leaf lah. But again, in this subject, we are not going to draw the tree. Okay, we will be drawing a stem and leaf diagram, means it will be in table, in table form. Okay, and make sure the data is in ascending order. And then the advantage is that the information on individual observations will not be lost because we use the raw data and we just arrange them in a table. That's it. So the data can be preserved. Okay. So for example here, so the table gives the number of days on which rain fell in 36 consecutive intervals of 30 days. Okay, so here you see, in 36 consecutive intervals, so we have this different data, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 3, so we have 36 consecutive intervals. So we take the reading. Okay, so we take the reading. Okay, so now there are 36 number of readings. So we can say that n is 36 in this case. Okay, now how to draw a stem and leaf diagram? Okay, so with the following class interval, Okay, so now we are given this interval. So how can we draw? Okay, so now you see the data, they come in two different types of digits, right? One is, okay, the first one is one digit number. Okay, 7, 8, 8, okay, 7, 5, 8, okay, 9 and 8, while the rest are in two digit numbers. So this one is one digit also, and then the rest come in two digit numbers, okay, 12, 18 and so on. So okay, how can we okay draw the stem and leaf? Okay, so first, okay, because the class intervals here are given, so now, okay, from, okay, for 5 to 9, okay, so we are going to identify, okay, which data will fall into this interval. So for example, okay, for 5 until 9, so we just look for any values that fall into this interval. So for example here, 6, okay, 8, 9, 9 here, 8, okay, and 8 here, okay, so this 7 also, 9 and 8, and as well as 5, okay, so they fall into this interval, right? So we can see how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there are 11 here. Or am I missing any? Yeah, so we do have 7 here. Okay, so there are 12. Okay, so there are 12. Okay, there are 12 readings that fall into this interval. Okay, and then next, we look at the second interval, 10 until 14. Okay, so you just identify which data fall into this category. Okay, so then, hold on a second. It just goes missing. Hold on, I'm going to get my OneNote document back. Okay, so now let's see. Alright, okay, so now let's identify which data fall into the second category. Okay. So now we see here number 12. Okay, so we go through the first row first. So number 12, number 11, okay, then number 13, number, what else? 11 here. And going through the third row here. Okay, so you see how many greens are there? 2, 4, 6. Okay. Yeah, so now we have 6 data which fall into this category, and you do the same for the rest of the data. You identify the intervals that they fall into, and then you just okay, now the stem. The stem here, how are we going to choose the stem? So here, because this is ones digit number, right? I mean ones digit, yeah, ones digits, okay, or tens digits, okay, and hundreds digits. So this is what we call as ones digit number, okay, nombor besar. Tens digit ni nombor puluh. So if you see 5 until 9 are the ones digit number, right? So now, okay, which means if, okay, the okay, if we try to write them down in two digits number, that means the front value, the front number will be 0. Okay, so the front value will be 0, so that's why we put 0 here. Okay, while for the second interval here, you can see that, okay, there are tens digits, right? So tens digit, and you can see the front number is 1, so that's why we put 1. And then the third interval also, the front digit is 1, and then we put the 1 to represent the tens digit. And this one also we put 2, okay, to represent the tens digit, because okay, the values here in this interval in 20s, okay, 20s reading, right? Okay, 21, 22, and so on. Okay, so we put the stem, and basically the leaf are just the values here. For example, okay, if the first data here, the lowest value is 5, right, just now. So 5, okay, so this is where the 5 is. So you just put the 5, and we just arrange the values here. So we have 5, 6, 7, 7, okay. And now here we have 11, okay, coming to the second interval. Okay, the first number, the first value begins with 11, 11, okay, you can see there are two 11s here. So you put 1, 1, okay, 2, 3, 3, 3, and then so on and so forth. All right, and then okay, you must provide a key. This key is a guide. Okay, so the key is provided to guide your readers. Okay, so this is to guide your readers, because okay, you just assume, okay, you just assume yourself as statisticians. Okay, we are now statisticians. Now we need to present this data to outsiders, okay, to people out there. So, and if they just look at the numbers here, how can they know that these data are actually the representation of what? Okay, and how to read the data. Okay, so for example, if they just, okay, if they are just given the table without the key, then they will not be able to read the data correctly. For example, they may question, okay, the 0.5 here represent what? The 0.5 represents 0.5 or what? Okay, so they might question. So the use of key is to guide your readers. Okay, so to guide your readers, okay, so that when they read the table, so given the key, so they will know. Okay, for example, here we give the key 1, okay, 1, okay, with this vertical bar, 1/6 means 16. So they know, okay, actually 1/6 here represent 16, while 20 here represent 20. So and they represent number of days. Okay, so that's the purpose of key. Yeah. Okay, and yeah, I noticed there's one question coming from Andrew. Okay, so Andrew says, Madam, I don't understand the key for the stem and leaf. Okay, so again, the key is basically to use to guide. Okay, basically the key is used to guide your readers. Okay, so you have to guide your readers based on the interval that you choose. Okay, for example, again, okay, for example, if yeah, okay, if we label the key here, okay, so because the data is about number of days, right, on which the rain fell. Okay, so now this 1/6 means 16 days. All right. Okay, and then 1/1 here means 11 days. All right, so that is how we provide the key. Okay, so for example, if your data is given in intervals, then for example, okay, we are talking about pointer. Okay, so the raw data pointer of students, so 3.45, and then 3.9, and then 2.8, and so on. So, okay, your stem may be, okay, given as this. So you just put 2 here and 3 here, and here you may put the 4.5, sorry, 2. Okay, so the lowest data is 2.8. So we put 2.8 here, and then 3, we put 4.5, and then we put 9. Okay, so here, which means this one 90, and this one 80. Okay, so then you put the key. So you put the key, okay, to help your reader to read the data, right? So 2, and you put the vertical bar, 80 means 2.80. So we know that the data that we are reading, okay, from the table is about pointer or CGPA. So that is how, okay, it helps, okay, the key. So again, whenever you draw the stem and leaf, make sure to provide key. Okay, okay, good, Andrew. Dah faham dah. Okay, so now let's continue. Okay, so now we do have okay, the same data, but we need to express using different intervals, yeah, because okay, let's say if it's not stated the interval, so okay, it's not fixed, you may just choose the interval, the suitable interval for you to represent your data. So now using the same data, how are we going to express, or how are we going to arrange them using this interval? Okay, so the problem will arise if you see this interval. Okay, just now we put the okay, the tens digit. Okay, for the tens digit, we put the front number to be 1, 1 and 2, right? Nombor puluh tu semua tadi kita letak 1, 1, 2. Okay, while for the ones digit, untuk nombor besar tadi, okay, we put the front value here, the stem to be 0. But now, the problem is with this interval. Excuse me. So the problem is with this interval, 19 until 21. So how are we going to choose the stem value? Okay, because if we choose 1, Then how are we going to represent the value 20? So in this case, we cannot choose the front digit or the first digit here to become the stem, yeah, because here the conflict will come for this particular interval. So that's the problem. So now, okay, the stem can be chosen, okay, using the lowest value here. For example, or actually here, if you notice, okay, we just take the, okay, now for the 4 to 6, 7 to 9, okay, so we will choose, for example, okay, this one will begin with 5, 10, 15, 20, okay. So this 4 will represent this 1, 2, 3, 4, 5, 6, 7. Okay, so now how are we going to represent the data? Okay, so we just take this, okay, for example, the first value is 5, right? So we just put 5 here and we just put 0. Okay, and you see the second value is 6, right? From here, the second value is 6, but we're not going to put 6 here. We put 5 here and we put 1. Why? Because, okay, later we're going to give the key. So 5, 1 is going to mean 6. Yeah, so and then here 5, 2. So 5, 2 means, okay, 7. So in this case, you see the third observation is 7, right? So how are we going to obtain 7 is by simply adding 5 with 2. And here 7 also, we add 5 with 2. And then how to get 8? We just add 5 with 3 and so on. And we do the same for the rest. So for example, you can see the last observation here from here. 2, 4 means 24, right? In the first table. But now we see we have 24. So in this case, 24 means 24. It's just about adding. We just add the value here. This one 5 plus 1, this one 5 plus 2, and then 20 plus 4. So means 24. So that's why the key is very important. Okay, so you can see from this example that one particular set of data can be represented using two different stem and leaf diagrams. Okay, so for example, it is very subjective to the statisticians or to the person who analyze, okay, who analyze the data. Okay, so it depends on you on how you want to represent your data. So okay, again, using this, okay, even though we have one particular set of values, but still we can use two different stem and leaf to represent our data. Okay, so the idea is, or the conclusion I would say, for this stem and leaf, okay, so I have given you in this summary. Okay, so you may refer in the summary. Okay, so I have put here, okay, summary, there are two important things, okay, to consider. Whenever you sketch or whenever you plot the stem and leaf diagram, make sure you provide key. Make sure the key must be given. And the second thing is equal intervals must be chosen. Equal intervals mean, okay, if you have, okay, if you can see from the notes, equal intervals. So in this case, okay, all the intervals are given equally. Okay, with the width here, you can see the difference here is 3. Or the class interval here is 2. 12 minus 10 is 2. And then 13 minus 15 is 2 and so on. Okay, so that is how we identify the class interval. They must be equal width, yeah? Okay, so now again, then the second type of stem and leaf is back to back. Okay, back to back means if you have, okay, so this is what we call as back to back stem plot. Okay, back to back stem plot. When you have two different sets of data, okay, you want to compare. So for example, if I do have two practicums, S12T5 and S12T6, I want to compare them, okay, their performance in UPS1. So I can do this back to back, okay, because, okay, when we have two sets of data, we just want to compare. So what we can do is, this is back to back, because here, okay, this is this is stem. Okay, you will have a single stem, but two different leaves. So this is your leaf and this is your leaf. Okay, because the marks, okay, so this is about marks, okay, marks of examination, right? So they are given in tens digits. So we use all the stem here to represent the first digit number. while the leaves, okay, will represent the second digit number. So for example, here you can see for the mathematics score, so the lowest mark is 31, right? So we put 3 here, we put 1. Okay, and you must provide the key here lah, so that, okay, the reader will be able to read your table correctly. So for example, it's quite different from the previous. So if you have 85 means, so 85 means 58, not 85, because it's located in this direction where your stem comes after your leaf, not the other way around. But for the physics here, for example, if you have 63, then it means 63. So it's quite different from the mathematics score to, again, the reading of mathematics score, because the stem comes after the leaf. While for the physics here, the leaf comes after the stem. So it's not a problem. But again, you have to provide key for both. Okay, so there is also one question. Let's see. Okay, Junlong asks, Madam, why the bee don't need to follow the interval? Okay, now let's see. The bee here. Okay. Why they don't need to follow the interval? 1, 2, 3, 4, 5, 6, 7. Okay, by the way, if you have a look at this data, okay, so this this is the representation of the data for the readings between 4 to 6 and 7 to 9. While this is the data representing for the interval 10 to 12 and 13 to 15. While this is the representation of data okay, from 16 okay, so from 16 to, hold on, so this one, the highest one is 13, right? This is 13, so which means that 13, okay, and then this one is, okay, this one is the 16 to 18. And then this one is 19 to 21. Okay, so now talking about these class intervals, so I would say that this one is, I think this one is using the different interval. Okay, this one is using different interval. So which means the data here is represented from 5 until 10. This one is from 11 until, this one is 15 until 19. Okay, 4 until 9. Okay, and then here 11 until 14, and then 15 until 19, and 20 until 24. So this one is the stem and leaf using these intervals. Okay, so in order to use these intervals, okay, so if you want to use this interval, so I would say that you are going to have 1, 2, 3, 4, 5, 6, 7 different stems. Okay, so 7 different stems where, okay, so actually the stems you have to follow the intervals provided. So okay, So we will do this. Okay, stem and leaf. So we will put 4, 7, 10, 13, and then 16, 19, and 22. Yeah, if you just want to follow exactly the intervals here, so this is what you can do. So for example, to represent the data 5 here, so we just put 1, and then 6 here, we just put 2, so on and so forth. So for the data 11 here, we just put, because 11, it falls into this interval, right? So 11, so we just put 10 and 1. And then for the data, okay, 8 here, so we just put 7. Okay, for the 7 here, we just put 0, 0, and 8 here, we put 1, 1, 1, 1, 1. Okay, and then for the 9, okay, it falls into the second interval as well. So we put 2 and 2. Okay, so if you want to follow the interval, okay, so this will be the 7 stems altogether. Okay, and we just arrange, and we just provide key. For example, you may provide key 4, 1 means 5 because it represents the addition. Okay, so the key will be 4, 1 means 5. All right, okay, now there is one more question. Okay, Andrew asked, then why the stem 1 need to write 2 times? What do you mean, Andrew? Oh, okay, because there are 2 intervals with 1 as the front digit. For example, okay, now let's see. Okay, at the A here, example A. Okay, 1 we write 2 times because, okay, when we talk about equal intervals, they don't really have to be same difference here. Okay, we are not talking about the difference in the stem. We are talking about the difference here in the intervals. So as you can see, okay, based on these 2 intervals, 10 to 14 and 15 to 19, the first digit is 1, right? So that's why we put 1 here. So this one is to represent the lower interval here. Okay, the one here is to represent the lower interval 10, while the one here is to represent the 15 interval. Okay, so does it answer your question? Yeah, typo 2, yeah, but yeah, I do understand your question. Okay, so that is how basically how we express the data. Yeah. Okay. Yeah, and I just this one, yeah. So this one, I would say this is, yeah, this is not the answer for the B part. Yeah. So please, okay, sorry for that mistake. Okay, so this is supposed to, okay, thank you Junlong for noticing that. So this the final answer for this is supposed to be this one. Okay, because I didn't notice there was basically 3 different questions. Yeah, but I just took this answer for different question. Okay, so here basically this is the answer for the this is different notation, or this is different stem and leaf for the A part. This one is also the same answer as the A part. Yeah. Okay, so this would be alternative. Okay, so this is alternative to A part. Then this is the answer for the B part. Okay, because the problem here will happen when you have 2 different digits number. So for example, here the front digit is 1 here and the front digit is 2. So how can we do this? So we are going to use the key to represent the sum of the 2 values. So for example, here to represent the first digit, we put 4 1 and it means 5. Okay, and then when 7 0, so it means 7. Okay, so okay, so I think I will give you the correct answer. Okay, so this is the correct answer. It's supposed to be then 10, 1, 1, 2. Okay, and then here you will have 0, 0, 0, 2. And then you will have 16 here, 0, 0, 0. And you are going to have 6 ones. Okay, so Okay, I will make correction. Okay, so you will have 6 ones. And then you will have 2 twos. Okay, because the twos here are going to represent the value 18. Yeah, because here in this case we do have 2 18s. And then for the 19, we put 0 here. Okay, and then for the 20, we put 1, 1 and 2. And then here we do have 0 to represent the 20. And we put 2 to represent the 24. Okay, so again, yeah. Okay, so this is basically, okay, the answer that I provide in the B is actually the alternative of A. Okay, and this is supposed to be the answer for the B part. Yeah. Okay, so I hope that you are able to see the difference. Yeah. Okay, the difference between the stem and leaf. So again, basically using one particular set of data, you can use different stem and leaf diagrams to represent them. So, and it just depends on you on how you're going to represent your data. Okay, yeah, is that clear? Okay. Okay, do you have any other question to ask? Yeah, and I don't think that we will have enough time to discuss 6.2. Okay, so because the next one is going to be 6.2 discussion. So this is all about it, yeah? Okay, so again, I would say this is the answer. Okay, this is just alternative of the A part. Okay, so we do have two different ways to use, okay, to draw stem and leaf plot now. Okay, for the A part, while for the B part, okay, we have only one because again the problem will be in this interval 19 to 21. So we cannot use the front digit to represent the stem because in this case we do have two different numbers, 1 and 2. Okay, so we will not be able to put 1 or 2 here because the stem usually it will represent, okay, it will be represented by one particular numbers only. Okay, and we cannot have options like this one, 1 or 2. So it has to be either one then, okay, either one between them. Okay, so that is all basically about stem and leaf. Okay, and you may try to do the tutorial question on plotting stem and leaf diagram. Okay, and tomorrow we will discuss 6.2. Okay, measures of location. Okay, so thank you guys. All right, any other question? Okay, so okay, anonymous start there. So now do you understand on how to draw stem and leaf plot? You may comment in the live chat now. So let's go through the summary. So this is all basically about 6.1, okay, that we discussed just now. Okay, so again, quantitative data can be measured objectively. Qualitative data can be observed subjectively. Okay, and then this quantitative can be, okay, categorized into two different types. One is discrete, one is continuous. So discrete is when you have countable values. Okay, and then for continuous data, okay, there are non-countable values. For example, weight, okay, interval, and so on. Then group data, so the keyword here is interval. And for ungrouped data, so they are just listed as sequence or in the form of a frequency table without the use of intervals. Okay, and then when it comes to stem and leaf, so you have two conditions for that. Yeah, so you have to provide key and equal intervals must be chosen. Okay, so equal intervals, it doesn't have to be between the stems, but the equal intervals have to be, for example, okay, like this one. Okay, the equal interval means it's not about the stem values. Okay, but the equal intervals is with the, okay, the equal intervals is with this, okay, is with this intervals itself. Okay, yang ini kita namakan dia interval yang sama. Okay, so it doesn't have to be the difference of the stem. Kalau kita tengok dari, okay, secara kasarnya memanglah tak ada nampak perbezaan kan kat sini. 0 and 1, the difference is 1. 1 and 1, the difference is 0. And then 1 and 2, the difference is 1. So, okay, kalau kita tengok dari segi nilai stem, kita mungkin rasa bahawa they are not equal interval, but we refer back to this interval that we want to categorize the data into. Okay, so first thing first, you identify. Okay, so one last question. Okay, coming from Jiva. All right. Madam, sorry to interrupt, but do we need to state the class interval if it's not required or mentioned in the question? Okay, so you don't really have to state the interval, but okay, when we read the table, we can see, okay, we can see the equal interval, and you just need to provide the key. Okay, so the equal interval is not stated directly, but we can tell actually from the stem and leaf plot. Okay, so the one that you have to state clearly is the key. All right. Okay. The sometimes and even the question, they don't give you the intervals, so you just need to determine. Okay, you identify the intervals, and then from there you categorize the data into the intervals, and then you start plotting your stem and leaf diagram. Okay. So again, sorry for the inconvenience. So this one, actually this is not supposed to be the answer for B. This is supposed to be alternative for A. Okay. So the answer for B, I just okay, I just provided here. Okay, so I hope okay, later when you print out the notes, you can you can just copy this stem and leaf diagram and you put in your notes. Or you may try to do it yourself for the B part. Okay, so again, guys, thank you for your attention, and thank you also for your presence. Okay, so that's all for today. Okay, thank you. Have a nice day, everyone. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, good, Jiva. All right, my pleasure. Gracias. How to respond? Bukeci. Okay, I'm gonna add the broadcast.